Hello, geometry students. This is Missy McCarthy, Okemos High School math instructor, and here's your lesson for section 2-3, using deductive reasoning to verify conjectures. By the end of the video, you should be able to say, I can determine whether inductive or deductive reasoning is being used for a given scenario. I can apply the law of detachment in logical reasoning and determine if it's being used validly. I can apply the law of syllogism in logical reasoning and determine whether it's being used validly. And I can use deductive reasoning laws to draw conclusions. So deductive reasoning is a slightly different way of thinking about things than inductive reasoning. Deductive reasoning is a process of using logic to draw conclusions from given facts or definitions or properties. So you start with general principles for deductive reasoning, and then you draw specific conclusions or specific instances. Versus inductive reasoning, you start with specific instances, and you notice a pattern, and you draw general conclusions. So it's a slightly different way of drawing conclusions. So in this example, we're going to determine whether or not we were using inductive reasoning or deductive reasoning to draw a conclusion. So it says there's a myth that you can balance an egg on its end only on the spring equinox. A person was able to balance an egg on July 8th, September 21st, and December 19th. Therefore, the myth is false. So was this person drawing a conclusion that the myth was false based on general observations or specific instances? I would say doing it on July 8th, September 21st, and December 19th are all very specific instances, and they made a general conclusion that the myth was false, so they were using inductive reasoning. So for part B, it says there's a myth that the Great Wall of China is the only human-made object visible from the moon. The Great Wall of China is barely visible in photographs taken from 180 miles above the Earth. The moon is 237,000 miles from Earth. Therefore, the myth cannot be true. So this is actually an example of deductive reasoning. Why is it deductive reasoning? Because we used facts and logic to draw a conclusion. We use facts and logic to draw a conclusion, not specific instances or cases. What were the facts that we used? We knew that it was barely visible 180 miles above the Earth. We knew that the moon was 237,000 miles above the Earth. And so we drew a logical conclusion that it definitely could not be seen from the moon. So those are the two differences between inductive and deductive reasoning. Now, one law of deductive reasoning is called the Law of Detachment. And it's actually a very simple law, but for some reason students overly complicate it. So I want you to keep it as simple as it is. And the Law of Detachment just says, if P implies Q is true, if that's a true statement, and P turns out to be true, then it's okay to draw the conclusion that Q is true. So if I say if an even number, if a number is even, then it is divisible by 2. Okay, so that is my if P then Q. So then I tell you that 8 is an even number. What conclusion can you draw? I'm telling you that P is true. 8 is an even number. You can draw the conclusion that Q is true. You can say 8 is divisible. 8 is divisible by 2. And that is an example of logical reasoning using the Law of Detachment. Okay, so we're going to use logical reasoning here to determine if the conjecture is valid by the law of detachment. So did they use the law of detachment properly here? So it says, given if the sides of the lengths of a triangle are 5, 12, and 13, then the area of the triangle is 30 square centimeters. Okay, so this is my if P then Q. This is my if P then Q. Okay, so if the sides are 5, 12, and 13, then the area is 30 square centimeters. Okay, so then they tell us that the area of a triangle PQR is 30 square centimeters. And they draw the conclusion that the side lengths of PQR are 5 and 12 and 13. Did they use the law of detachment correctly? So this is how they used it. They said if P implies Q is true, so that's the first part. But then this next part right here, I'm going to try to highlight it. This part right here, are they telling us that P is true or that Q is true? The second part about the area is Q, so then they're telling us that Q is true, and then they're drawing the conclusion that the sides are 5, 12, and 13. So they're saying, therefore, P must be true. And I would say that does not follow the law of detachment that we just talked about on the previous slide. So this is an invalid use of that logic. This is not a valid way to use the law of detachment. The law of detachment says if P implies Q is true, and you know that P is true, then that means that Q is also true. Okay, so let's look at this one. In the World Series, if a team wins 4 games, then the team wins the series. Okay, so our P to Q is this. If a team wins 4 games, then the team wins the series. So we're assuming that's true. Next, they tell us that the Red Sox won 4 games in the 2004 World Series. So they're telling us that P is true. So the conclusion that we can draw is that the Red Sox won the World Series. And that's what they said. The conjecture is that the Red Sox won the World Series. So Q is true. So that is a valid use of the law of detachment. That works. It followed the process. If P implies Q is true and P is true, then that means Q is true. All right, the second law, and this is the last law actually, it's called the Law of Syllogism. Funny word for a simple concept that you guys use all the time. And the Law of Syllogism says, if P implies Q and Q implies R, then P implies R is a true statement. So here's what that would look like. If a triangle is obtuse, then it has one obtuse angle. Okay, so that would be my first P implies Q. So I would say if a triangle has one obtuse angle, then it is not a right triangle. So that would be my Q implies R. So my P, oops, I'm going to highlight here. This is my P, a triangle is obtuse. This is my Q. It has one obtuse angle. Then it says Q to R. So this is my Q. If a triangle has one obtuse angle, then we've got R. Then it is not a right triangle. Okay. So then it says P to R is true. So that means you can cut out Q. So that means for my final statement, I should be able to do P, which is yellow, cut out the green in the middle, and then Q, which is R. So my final statement should say, and let me get that in black ink here, if a triangle is obtuse, then it is not a right triangle. So if P implies Q and Q implies R, then P implies R. Okay, so we got to determine whether or not they validly use the law of syllogism. So angle A is 90 degrees. I'm going to do it with the colors again. So if the measure of angle A is less than 90 degrees, oops, I was going to do that in yellow. If the measure of angle A is less than 90 degrees, then angle A is acute. If angle A is acute, then it is not a right angle. So P to Q, Q to R. So our final should be yellow to blue. Let's see if that's the case. If angle A is less than 90, that was yellow, then it is not a right angle. That was blue. So we cut out the middleman. So is this a valid use of the law of syllogism? And my answer would be yes, this is a valid use of the law of syllogism. Okay, last one. If a number is divisible by 2, then it is even. If a number is even, then it is an integer. So let's go with our colors yet again. Start off with yellow. A number is divisible by 2. Then let's go to green. Then it is even. If a number is even, then it is an integer. Then it is an integer. Okay, so then the conjecture says if a number is an integer, that was blue, then is divisible by 2, that was yellow. Is that a valid use? We should go yellow to green, green to blue, yellow to blue. But this goes yellow to green, green to blue, blue to yellow. And that is not the correct way to use the law of syllogism. So this is not a valid use of that law, not a valid use of that type of reasoning. Okay, so now we're just going to draw some conclusions using the two laws of deductive reasoning. So here is our first example. If triangle LMN is translated in the coordinate plane, then it has the same size and same shape as its pre-image. If the image and pre-image have the same size and same shape, then the figures have equal perimeters. So this part is going to be my P. This part is going to be my Q. Then this part about them having the same size and same shape as Q. And then this part, they have equal perimeters, is R. So if triangle LMN is translated in the coordinate plane, my conclusion would be triangle LMN and its image have equal perimeters. And that was using the law of syllogism. That would be the conclusion that I can draw. So this one says, if two angles form a linear pair, that's P, then they are adjacent, that's Q. If two angles are adjacent, that's Q, then they share a side, that's R. Okay, so then we got angle 1 and angle 2 form a linear pair. So that means angle 1 and angle 2 share a side. And that again was another use of the law of syllogism. Okay, so here we go again with our I can statements. Determine whether or not you're using inductive or deductive reasoning. Use the law of detachment and the law of syllogism to draw conclusions and to determine whether or not they're being used validly. Okay, so that's what we were doing in this section. We'll see you in class.